Hey guys, in this video I'm going to show you the prep work we're doing to create our off-grid system. We have one running right now which is hooked up to trailers outside, which are a duplicate of what you see here. These are two SMA 6048 inverters, master and slave. They're both 120 volt single phase, but you use them in combination and you get L1, L2 in neutral and ground that then you could use to power your equipment. These are the bus bars, copper bus bars, that are going to be for the, this is for the positive, and this is for the negative. This is the shunt, that is a Victron shunt, but we're also going to use it to supply the signal to the SMA, because it's a 50 millivolt shunt, and it'll perfectly work with this. Up here, this is the inputs for the current, and then up here is the battery temperature. So we're going to be running a cable through here that then goes to the batteries. So we're going to be installing these big battery, Congolese batteries, which are 15.5 kilowatt hours each, for a total of 31 kilowatt hours. And down here is the where they'll go. So up here you can see this is SMA Data Manager M, and this is going to be connecting between here via RS-45 to the first inverter, and then it's also going to connect via Ethernet to the internet, and then the second one is going to go over here to an SMA Sunnyboy 7.7 US inverter. So this is hooked up to 23 panels, 315 watts a piece, on 3 strings, and we've changed our configuration to 3 strings. When you knock on this, it gives you the voltage and power. So yeah, we're doing 213 watts, 2,300 watts right now. And that inverter ties into this off-grid panel right here. And this is moving, this off-grid panel goes to different loads that we have, and I'll show you that here. I'm going to take a pause, but before that I'm going to show you this. This is a Rasberry Pi running Victron OS with the custom software that's meant to interface here. That software came from somebody's GitHub, and it works pretty good. What it does is it's able to talk to the inverter and get from the inverter the power coming or going from the battery, its voltage, current, and then it's telling you what's going to the loads. What's missing is any DC solar power that's coming into it, but it's good enough because it really is telling me 2 things. You know, what the battery draw is, and that's coming from a shunt, and then this is actually coming from just RS-45 communications via CAN bus to the inverter. Actually, sorry, I should just call it CAN bus, and this is a CAN bus adapter that specifically works with this software. So this is plugged into via USB to the Raspberry Pi, and then this recognizes the CAN bus adapter, and now we're able to talk on the CAN bus to the battery side of the inverter, which is this side here. So this would be like what you'd have if you had a lithium-ion battery pack with a BMS that talks to the SMA. This is allowing that data communication. Now, this data communication is coming from not these 2 inverters, because these aren't commissioned yet. There's 2 duplicate inverters, like I said, outside in a trailer that are basically going to be decommissioned once we go to this and we go inside with batteries. All right, I'm going to show you the switch boxes that we have on the load side. So we have these control panels that allow us to switch between the loads that are on the TP is our electric company. So either we're down and we're pulling from the electric company and bypassing the solar, or here when we click it on this is pulling from the SMA Sunny Islands for the power. Or they're getting from the Sunnyboy, because these SMAs, we have them AC coupled. And then this is the breaker panel. So basically, yeah, I'm sure you could watch videos on this ProTrans and you'll see how it wires in, but it's connecting to the load getting its input from a circuit breaker and then sending it to the load, and then the circuit breaker is the input from the utility company, and then on the other side you've got connections that are going to that off-grid panel that I have that give the AC feed to this. So this is doing all our office loads, and then this is doing one air conditioner. So we have about a 4 kW air conditioner that we're able to power from this unit. So this is one of 2 switch boxes. This is the second switch box. So you can see that we pretty much have everything hooked up to the SMAs, or actually that load panel, off-grid panel. So this is the switched off, so that's getting it from the electric company. But I don't know if you know how the SMA works, but let me go over there and explain it to you. So what the SMA does is it creates a microgrid, okay? And it takes power from the batteries, it converts it into AC. That AC gets fed into this off-grid panel here. And let me pull the cover on this. There's the panel's off, so 1 second. All right, so the power from the SMAs, in this case we're using 2 breakers to feed it, but I think 1 is sufficient. Actually, only one of them is on right now. So the power from the SMA comes in here. What it does is it creates a grid, much like the electric company. That grid then allows the Sunny Island DC to AC inverter over here to turn on. So it's basically syncing with the grid that's created from the Sunny Islands. So you can see it's in an off-grid 60 setting. Okay, so it's getting its frequency from it's getting the grid source from the microgrid created by the Sunny Islands. Now what the Sunny Islands do is they essentially throttle the solar by shifting frequency. So obviously that SMA is compatible with the Sunny Islands because they're made by the same company. It reacts to a frequency shift, and let me show you a frequency shift. So right now I would expect the frequency to be low because we're pulling a lot from the battery, meaning that the solar it's probably shading outside. Let's click over and see, or the AC is on because it's late in the day. If you go to, so this shows you, okay, so what's happened is the frequency, sorry about that, the frequency is at 59. That's the lowest, so it's wide open. It's demanding full power from this inverter in the corner, right? But the sun is low enough right now versus the loads that the solar is wide open, but we're still pulling 2346 watts, and that's really because the AC is on. And so if we can shut the AC load down, which I'll do right now, and come back, you'll see that this will drop. Okay, I just shut the AC off. So you see it coming down. The fan's probably on, and then it's going to come down even further. So it's still, the load is still, the amount of solar that we're producing is still exceeding the what's possible from the sun. So you could see 1300 watts. The reason it's saying 1300 is really some of this is coming from let me show you outside, because this is probably confusing because I haven't showed you the outside system. So this is a trailer that has solar panels on it as well. So you can see it's making 641 watts. So some of the power is coming from this, as well as some of the panels coming from the 23 panels on the roof. And then there's that another Rasberry Pi. This is from the Victron Data monitoring through their portal called VRM. So we saw 630. Coming back. So we're still pulling from the battery. So to reduce this, so essentially sometimes during the day when it gets late in the night, I tend to switch off some of the loads that I know a given load, right? I know that the shop lights, for example, take 1300 watts. So all I have to do is shut this off, far right one, and now we can go back there and we'll be matching our generation and not really pulling from the batteries. Reason for this setup inside, one is temperature, and two is putting a larger capacity battery bank, but three is going with lithium ion so that I don't have to really always be shutting off and on. Came down a little bit. Should have been going the other way. But if I switch off more load, then we'll be better matched. We wouldn't be pulling from the battery. But the other thing that could have happened is that maybe the frequency shifted. Nope, it's still demanding. When the frequency is low, it will be demanding full power. When the frequency goes up, it starts throttling the solar coming from the inverter in the corner. Okay, there we go. So the sun picked up, there was shading, so this makes more sense. So by taking that 1300 watts, now we're charging the battery. But yeah, like I was saying, the reason that we're going inside is to have batteries with reasonable temperature. This is Arizona where we're located, and also to go with lithium ion, so I can get more than, right now I'm just using lead acid maybe down to 70 or 80%. I'm going to try to cycle these down to 20% every day, and then I plan on leaving all the loads on at night except for the air conditioner. And by on, I mean that this off-grid system would provide the power to them. Of course, I would try to reduce my load by shutting things off, but you know, there's water heaters, there's things that come on cyclically. So this is the setup, and we're just in the stage of doing it. The next steps are really doing all the wiring, you know, all the DC wiring, and then all the AC wiring. We're also going to be incorporating a generator. Right now this is a manual turn on for the generator, but we're going to put it like a three-way switch so we can manually turn it on, or we can have the SMAs turn on the generator. And that could be done by state of charge condition, like if the state of charge of the batteries drops below a certain threshold, or we could do it even to assist if the load goes above a certain wattage. And let's say we want to limit how much current we're pulling from the batteries, we could use the generator to augment the load. And so we have two options. This trailer we have here has a diesel generator, 11 kilowatt Kubota with a 113 gallon fuel tank. So we could, you know, park the trailer and power from this generator to the inside of the building. But the problem is this thing's like a school bus. When it runs, it's just kicking coal out. So we have in the building already a generator here, which is a Kohler, propane powered. Obviously this is a very small tank, but that switch that you see outside is for this generator. So I think our first step is we're going to hook this up, and if this works well, we'll try it and we'll use it, and hopefully when it needs to switch over to it is infrequent, so we can get away with that. If not, we might get a bigger propane tank, or we have the option, we've already plumbed it for natural gas. We don't have service yet for natural gas, but we could potentially get that and then use this system in that fashion. But I'm thinking we're going to take it step by step. Alternatively, instead of using the generator as the backup, we can use the grid as a backup. But this building is 208 three-phase, and these inverters are 240 volt split phase. So I think to be able to use the utility, we're going to have to use an auto transformer to give us 240 volt split phase coming from 120 volt. And you know, I've seen these auto transformers made by Solar Edge, and they're 5 kW. We may try that. I think that might be an option. Of course, with that level of power, we couldn't run the AC loads like we do now with it, but we'll try it. We'll try it out. So, but I think since we have the generator here, we'll probably start with that, and then we will add in the auto transformer, and we may even do a switch box that can switch between the auto transformer, which is essentially the grid, or the generator, using again, the Sunny Island. It has this one of these dig out. It'll control a relay, essentially. So you'll have to use a relay to make it say, hey, I'm on grid or I'm on generator, because there's different settings in the SMAs for what frequencies and voltages it allows for grid versus a generator. Generator, it's pretty loose on what it allows, whereas the grid, it's very tight on frequencies it allows. I hope that explains the setup. I'll go in more detail. I know I went over everything very fast, but I'll spend some time in future videos going over these different systems. Obviously, this is all going to get cleaned up as we go from being connected to the trailer outside. All this is now going to move its connections to these in here, and I'd like to show you some videos of how this SMA collects data. It's got a local portal, and it's got an online portal called Sunny Portal NXOS. So I hope this explained our setup slightly to you, and we'll continue to do these videos. Thanks, bye.